Hi, this is Professor Waits, and welcome back to Chapter 14. We're going to start out with object conversion in this video. So when it comes to object conversion, a type of an object can be converted to another. So we've seen this already in built-in data types. So we've talked about the ability to go from a double to an int, so forth and so on. And so this is similar to that, except that this is more about objects being converted to another object type. So in this, we've got the ability, so we're going to kind of use this feet to inches objects to an int as an example. And you must write the operator function to perform that conversion. So here is feet inches operator to an int. And it's going to just return feet. So assuming distance is a feet inches object, this allows a statement where we're taking distance, because they're saying this distance is a feet inches object, and converting it to the d. Now, what we know is behind the scenes is it's only going to return that feet, which obviously is an int. So that's one way of doing your object conversion. Now let's talk a little bit about aggregation. When you have a class, as a member of another class, so you've got kind of this class, and in its variables, you have another class. It's aggregation. And it supports this modeling of has a relationship between classes, including classes has a enclosed class. Now, what's interesting about this is they're trying to start to give you hints to one of the uses of objects, which is to model a record set. And in a record, you might have, a string, an int, so forth and so on, but you also may have what is known as kind of a foreign key to another record. And let's say that this is student info, and this table is student info. So we know that this is pointing out to another, so we have that has a relationship. So for example, in this, we've got this class, the class of student info, which again has a first name and a last name. It's got this address, city, state. It talks about a student, and in particular, that student's information. And then in this class student, we've got a private student info, which again relates up to this class. So this is a class has a relationship to that class. If that makes sense. And here is kind of that UML display of that, where instructor and textbook are obviously a part of this class. So a course has a instructor, and a course has a textbook. Now, in these next few slides, we're just going to kind of walk through them. I don't particularly like just reading slides to students, so I'll kind of cover them pretty quickly. You definitely are going to want to make sure you take a look at the book and understand by reading a little bit more about R-value references and move semantics. So one of the things to understand is when you do math like this, behind the scenes, that math, which that is 12, has to be stored in a temporary piece of memory while it's being transferred over to X. So this is first going to be temporary. What's then copied into X is more permanent, kind of permanent, and then this is blown away. And so we kind of talk about that in this value. The temporary value is then stored in the x variable, and then the temporary value is discarded, just like I said. So with that being said, the square function is called, and the value 5 is passed in. The square function calculates 5 times 5 and stores the results 25 first in a temporary spot. Then it's assigned to A. Then it's deleted, and then A is returned through the int. There you go. So the temporary value is copied, assigned into the variable x. The temporary value is no longer needed, so the system discards it. We've talked about that. All right, L values and R values. There are two types of values stored in memory during the execution of the program. Values that persist beyond the statement that created them have names that make them accessible in other statements, and these are known as L values. So int x, that's an L value. When this math is done and it's stored temporarily, that's R value. But as soon as returned and then stored in here, it now becomes an L value. R value references. So, you got a reference variable that can refer only to a temporary object that would otherwise have no name. Remember, a lot of these memory spaces, they're talking about, did I lose my pen? R values. Sorry. So R values are temporary. R value references are used to write more constructors write move constructors and move assignment operators. We'll talk about that in a second. Otherwise known as move semantics. Anytime you write a class with a pointer or a reference to a piece of data outside the class, you should implement move semantics. Move semantics increase the performance of these types of classes. Now, I know you're saying, Professor Waits, what do you mean we should consider using move assignment? Is there something else? Well, yes, there is. There is the copy assignment. This is exactly how it looks different. When you move something, you take something that's in memory and move it to another place in memory. When you use the copy assignment, you actually copy a piece of information that is then stored into another spot. So take a look at these segments and you can see where the swap is moving, and now you're using a new char, so you're allocating new memory and then you're copying into that new memory. So from the person class in chapter 14, you can see that a move constructor just takes what's in the temp name, moves it into the name, and then makes this temp name point to a null pointer, thus killing it. Where in the copy, we're going to make a whole new memory space for this. And then we're going to copy what was in this to what is new. All right, this is the end of chapter 14. I hope you all had a great time with this lecture. And if you have any questions or concerns, please shoot me an email, and I will do my best to get back to you as quickly as possible. All right, you all have a great time, and we'll see you in the next chapter.